Hello everyone, I am Surendra, Master Teacher of Mathematics in Vedantu. In my sessions, my series for ISI and CMI preparation, which are also helpful for JEE Advanced and JEE Mains. Today I have taken a topic of finding the range of rational functions by alternate methods. First, what is the rational functions? When we write a function in numerator and denominator, where in numerator we have one polynomial and in denominator we have another polynomial. We call this kind of function as rational functions. The example for this could be linear in numerator upon linear in denominator, or quadratic in denominator, quadratic in numerator upon linear, or linear upon quadratic, or quadratic 1 upon quadratic 2. This alternate method you will find very useful, especially when domain is not entire R but it is some part of R. So to start with, let me take this linear upon linear concept. So this is the standard form of linear upon linear, where x cannot be minus d upon c, otherwise it will become 0, hence this will be not defined. Also, I have taken this condition because if a upon c become equal to b upon d, then you can check this y will be just a upon c, because for all values of x, numerator and denominator will get cancel the terms of x and you will be having just a upon c. That's a constant term, so we will not like to call that as a linear upon linear. So that's why this condition. Now, how to do these questions by normal method? I think we normally do these questions by cross multiplication. I have taken this example. If we do the cross multiplication, we will get 3xy plus 2y is equal to 2x plus 1, and I will write this x to be equal to 1 minus 2y whole divided by 3y minus 2. So you can check, because range means values of y. So here range will be every real value except the value where this denominator will become 0. That means 2 by 3. And dear all, I will like you to remember, it's a must that for such function you should know that range is always r minus the ratio of coefficients of x and x in numerator and in denominator, that is a upon c. Here always it will be like this. You can check it here also. 2 upon 3 is subtracted from the set of r. But why it is so? It is so because you may write this example. If I take like this, 2 by 3 taking common, you will be able to write this as 3x plus 2 minus 1 upon 3 whole divided by 3x plus 2. And then we get this to be 2 by 3 minus 1 by 3 whole divided by 3x plus 2. Now, this 3x plus 2 can take all real values from minus infinity to plus infinity except 0. Okay, and then if you put all these values here, this expression 1 by 3 whole divided by 3x plus 2 can never become equal to 0, because whatever large value you put in the denominator, 1 by 3 is a non-zero constant, you will always get small, or maybe very small, or very small, but never equal to 0. So if it is never 0, y can never take value equal to 2 by 3. So that can be the one reason why we are saying it will never ever become equal to 2 by 3. Okay, so that is the reason for any linear upon linear function you can think of. But I will tell you one more approach to think of the same thing, that is graphical method, and please see what exactly it is. Suppose we have this function and we are already aware now that domain is r minus d upon c and range is y belongs to r minus a upon c. Now dear all, if you do the cross multiplication and do some manipulation, you will be able to write this expression like this. And let me tell you how you can write it directly also. Here one of the bracket cx plus d is coming from the fact that minus b upon c cannot be the value of x, which will make this bracket to be 0. Similarly, another bracket is coming from the fact that a upon c cannot be the value in the range. That's why cy minus a. If you take minus d upon c as x or a upon c as y, left hand side will become 0, whereas right hand side is b c minus ad, which is not 0. That means we cannot have these two values of x and y. So understanding this fact, you will be able to write this directly, and you may remember that there is a BC minus AD on the right hand side, or you can do the calculation whenever it is needed. Now dear all, this kind of graph is actually a shifted form of this very popular graph, which is xy is equal to c square or xy is equal to minus c square. If you remember, xy is equal to c square is actually lying in first and third quadrant, okay, and this one is lying in second and fourth quadrant. Okay, if this is positive, then this one; if it is negative, then this one. In this case, center is at 0, 0. You cannot have value of x to be 0, y to be 0, and this is a point which we call as center. Here also 0, 0. In this case, you can check, because x is replaced by cx plus d, so center will have x coordinate to be minus d upon c, and y coordinate of center would be a upon c. Everything will remain same, means it will be shifted from here to here without rotating. It is just transformation. So here these lines will remain parallel to x-axis and parallel to y-axis. And you can see, because this x parallel to this x-axis is never going to touch this graph, so this is the value which this function will never ever attain. This graph is actually y is equal to a upon c. Similarly, this graph is y is equal to this graph is actually x is equal to minus d upon c. Okay, so in the domain minus d upon c cannot come, and in the range a upon c can never come. Here, when this right hand side BC minus AD is positive, you will have shifted form of this first one. If BC minus AD is negative, then you will have shifted form of the second one. Okay, so if you remember this thing, that how this graph is made, I think questions will become very easy. Let us see this question. I have taken the same example which we did in our first slide. Here, if I try to write like this, cx plus d into cy minus a, so the term of x should be this direct 3x plus 2. And remember, this term, this bracket is corresponding to the domain thing, that x cannot take value equal to minus 2 by 3, and y cannot take the value equal to 2 by 3. X cannot take minus 2 by 3 and y cannot take 2 by 3. So here, corresponding to y, the bracket would be 3y minus 2. Okay, now the right hand side was BC minus AD. So if you like to do that way, you can do it. Otherwise also you can do it. I think this will come out to be minus 1. Let us check. B is 1, C is 3, so 3 minus 4 minus 1. So this is what you will get after you do the simplification of this thing. Or you can say you write it in alternate form of, product of two brackets on the left hand side and equal to minus 1 on the right hand side. So which kind of graph do you see? It will be, I think this will be lying here in second quadrant and in the fourth quadrant like this. And this center would be at minus 2 by 3, comma 2 by 3. Okay, now if we are looking for the range when x is 0 to 2 or minus 3 to minus 1 and so on, I think this graph is going to help us in great way. Let me use one fair diagram of this graph. I think that was what we got here. Now for first part, 0 to 2, as you can see, minus 2 by 3 is here, so 0 will be lying somewhere here and 2 will be lying somewhere here. And from 0 to 2, if you check, this graph is always increasing. Yeah, one more thing, let me add here all itself, that this rectangular hyperbola graph is either decreasing if you take this case, or if it is increasing if you take this case. So here also it will be either strictly decreasing or strictly increasing. The same thing can be verified using dy upon dx also. Okay, so here what I was saying, for x from 0 to 2, you can put x is equal to 0 here and you will be getting 1 by 2. If you put x is equal to 0, you will be getting 1 by 2 here, and if you put 2 here, then it will give you 2 into 2, 4 plus 1, 5 upon 2 into 3, 6 plus 2, 6 plus 2 is I think 8. So the range would be 1 by 2 comma 5 by 8. Okay, don't get confused that this is below some x-axis. It is not x-axis, it is parallel to x-axis. Okay, because this y coordinate is 2 by 3, your x-axis actually will be lying somewhere here. Please understand that. Actual x-axis will be lying somewhere here. This line is corresponding to y is equal to 2 by 3. So for 0, the value is 1 by 2. Okay, and for 2, it is 4 plus 1, 5, and upon 2 into 3, 6 plus 2, 8. So range for this case will be 1 by 2 comma 5 by 8. Because this 0 is included, so close bracket here, and 2 is not included, so open bracket at 5 by 8. Isn't that simple? Tell me. Otherwise, you will be thinking that how to put values of x and how to get the range. Now coming to the second part, everybody listen carefully. Here I have taken these values which are lying on the left part, minus 3 to minus 1. So minus 1 will be lying somewhere here and minus 3 will be lying somewhere here. Now if you put minus 3 in this, okay, so this will give you at minus 3 the value will be 1 minus 6, so minus 5, and here it will be 2 minus 9, so minus 7, minus 9 plus 2, so it is 5 by 7 here, and for minus 1 if you put, it will be minus 1 here and minus 1 in the denominator also, you can check. Minus 2 plus 1 minus 1, minus 3 plus 2 minus 1. So here the range will be 5 by 7 comma 1. And we can write this with full confidence that this is going to be the range. Okay, now coming to the last part, that is the third part. Here we are given the value of x which is lying on both part of this minus 2 by 3, both sides of this minus 2 by 3. In fact, I can write minus 2 here and 3 somewhere here. Okay, my x-axis is somewhere here. Okay, now if we need to find the range, as my x ranges from minus 2 to minus 2 by 3, so this graph will go like this. Okay, and then excluding minus 2 by 3, this graph will be coming from minus infinity, and this we want to go till 3 here. Okay, so now what we need to do, we need to find the value at minus 2, which will be, if I put minus 2 here, so 1 minus 4 to minus 3 here, and 2 minus 6, so minus 4. So this will be 3 by 4 here. Let us check once again. 1 minus 4 is minus 3 and 2 minus 6 is minus 4, so 3 by 4, that's correct. And at 3 if you put 1 plus 3, 1 plus 6 actually, so 7 here, and 3 into 3, 9 plus 2, 9 plus 2, 11 here. Okay, so you can check the graph is going first towards infinity. So in this case range will be 3 by 4 to infinite. At infinite we have always open bracket, but at minus 2 I think we will have closed bracket because they have given closed at minus 2. And similarly then this graph will be coming from minus infinity comma, and then it will go up to 7 by 11. So that is the range. You may write it in correct way, that is minus infinity comma 7 by 11 union 3 by 4 comma infinity. So this kind of graph you can always find the range easily by making such kind of diagram. Okay, I'll take one more example. Suppose you are given y is equal to 2 into e power x minus 3 upon 4 into e power x plus 3, where x is from 0 to infinity. Now if I put ex is equal to t, then t will belong from 1 comma infinity, and then this graph will be y is equal to 2t minus 3 upon 4t plus 3. Okay, and if we write the way I told you, 4t plus 3 for that domain part, because t cannot be equal to minus 3 by 4 and y cannot be equal to minus 2 by 4, or you can simplify that as 1 by 2 also, but let me write this way only. So 4y minus 2, 4y plus 2 actually, sorry, this is plus 2 by 4, so 4y minus 2. Okay, now what will the constant term? If you remember, I told you it was BC minus AD, so minus 12 minus 6, I think minus 18 it would be, you can check. In case you want to verify, it will be 3 into 2 minus 6, if 18 is brought this side, minus 6 plus 18, so plus 12. Yeah, this is correct. This is correct. Okay, now you can see it is negative on the right hand side. So how the graph will be? Once again the graph will be like this. Okay, now if graph is like this, then and we are looking for t going from 1 to infinity, and this point is corresponding to minus 3 by 4 comma 1 by 2. So this 1 will be lying definitely here, and we are going up to infinity. So at 1, if I put it here, it will be 2 minus 3, so minus 1 upon 7. Okay, that is the value at 1, and you can see this time I think my x-axis will be lying somewhere here. So this minus 1 by 7 is giving us negative value. In fact, it can be checked here also that for corresponding x is equal to 0, x is equal to 0, this will be 2 minus 3, so minus 1 upon 7 here. So going up to and as my t approaches to infinite, this graph will be approaching toward this line only, and this line is corresponding to y equal to 1 by 2. So here the range will be, you can check, minus 1 by 7 comma 1 by 2. At 1 by 2 it has to be open bracket because we will never ever achieve that value, it will always be lying below it. At minus 1 by 7 also, because here we have given open bracket at 0, so at t equal to 1 also open bracket, so at minus 1 by 7 also this is the open bracket. So that is the answer for this particular question. So I hope you understood how linear upon linear is to be dealt with. Okay, now I'll come to quadratic upon linear. Okay, now how quadratic upon linears are solved? First of all, this is the general form of quadratic upon linear. Okay, in the numerator we have quadratic, in denominator we have linear. I have taken one example. Okay, and obviously r cannot be, this x cannot be equal to minus 1. Now what is the normal method? I think normal method is once again that you do the cross multiplication. So y into x plus y is equal to x square plus 4x plus 7. Then we make a quadratic in x square plus 4 minus y into x plus 7 minus y is equal to 0. And then we solve for d greater than or equal to 0. And whatever value of y we get, that is the answer for the range. 4 minus y whole square minus 4 into 7 minus y greater than or equal to 0. If I do it fast, I think y square minus 8 plus 4, so I think it will be minus 4y only, and 16 minus 28, so minus 12. 16 minus 12 is 12, 16 minus 28 is 12, so greater than or equal to 0. So I think minus 6 plus 2, yes. So y minus 6 is one factor and y plus 2 is another factor. So range here will be from minus infinity to minus 2, close bracket, union 6 comma infinity. So that is how we do such question. Now my question here is that, like my previous two questions, if my x is not all values of real except minus 1, but it is, let us say, 2 to 3 or say 10 to 15, something like that, then how we will do such question? Then I have one method, that is AMGM. In fact, I have integrated AMGM with graphical method. Let us see how this is done. In fact, I have made few cases. First case is when numerator has no real roots. Here you can check this is not having any real roots. So if you try to draw the graph of this function, you will have only one critical point, that is minus 1. In fact, minus 1 is something where there is a danger. Danger means you cannot put x is equal to minus 1 here. On the right of x equal to minus 1, there will be positive value. On the left, it will be negative using simple wavy curve method. As you try to put x equal to minus 1, approaching towards minus 1, this entire thing will become infinite. That you need to understand. At x is equal to minus 1, numerator is not going to be 0, but denominator will approach towards 0. So value very less in the denominator, a finite value in the numerator, it will be either infinity or minus infinity. So on the right of it, it should be going like this. And because numerator has degree 2, denominator has degree 1, so at x approaches to infinite, okay, if you put x approaches to infinite, numerator will have very, very large value as compared to denominator. So ultimately this value has to go at infinite like this. Similarly here also the value will be going like this, because at minus infinity this numerator will go to plus infinity, and to that to very large value as compared to numerator, because it is just linear. But numerator will be positive, denominator will be negative for x minus infinity, so this graph will go down this way. Now if you can find these points where minima are occurring, I think our job is done. Okay, so let us see first, this is little bit fair diagram, and now I'll tell you how to find these points where maxima or minima will occur. In this case, when numerator has no real roots, you may do it by make use of application of derivatives by doing dy upon dx, but I will tell you some other method. Please see what that is. I can write this as y equal to x plus 1 whole square plus, then 2x will be remaining. I will write 2 common x plus 1, and then constant term here I think it is 4, because 1 plus 2, 3 plus 4, 7, and whole divided by x plus 1. Now this will give you 2 as a constant outside plus x plus 1 plus 4 upon x plus 1. So I think you can see that it has actually become kind of a number plus reciprocal of that number. And we can find the value of this expression by use of AMGM. See, if x plus 1 is positive, then this thing will be x plus 1 plus 4 upon x plus 1 will be greater than or equal to, by use of AMGM, 2 into under root of 4, isn't it? And that will give you 4 here. And this equality will happen. Equality will happen if these numbers, that is x plus 1 and 4 upon x plus 1, they are equal. And x plus 1 is positive, so here we will get x plus 1 to be equal to 2. So at x is equal to 1, we are going to get this minima. You can check. This is going to be greater than or equal to 4. That means 4 is the value of minimum for this expression. And also we have to add 2 to this. So at 1, my minimum value will be, I think, 6. Similarly, now when x plus 1 will be negative, x plus 1 is negative, you can write x plus 1 to be equal to minus 3. And then this expression, which was x plus 1 plus 4 upon x plus 1, can be written as minus common t plus 4 upon t. I can now apply AMGM on this expression, which will be again greater than or equal to 4, but because of this minus sign, it will become less than or equal to minus 4. And in this case, equality will happen if x plus 1 is equal to minus 2. Because these two will be equal, x plus 1 whole square will be 4, and because x plus 1 is negative, so x plus 1 is equal to minus 2, that means x is equal to minus 3. So this point of maxima, because in this case, when you add this to 2 also, this entire thing is going to be less than 2 plus minus 4. Let me write this way, that when x plus 1 will be negative, my y is going to be less than or equal to 2 plus minus 4. Here I got this to be less than minus 4, so this y will be less than or equal to minus 2. So at this point that we found as minus 3, the value is going to be minus 2. So now you can check. The graph before this minus 3 was like this, that means increasing. Then after minus 3 till minus 1, it is decreasing. Then after minus 1 till 1, it is decreasing, and then again it is increasing. And you can check that our range is the same thing or not. I am getting range here minus infinity to minus 2, isn't it? Because going from lower side to this point, this maxima, local maxima you can say is minus 2, and then this is the local minima where value is 6 and it will go up to infinite. So you can check, this is the same thing we got by our earlier normal method also, minus infinity to minus 2 union 6 comma infinity. Now I'm not doing that question, but suppose somebody gives you some constraint value of x. Let us say x belongs to, let us say 0 to 3 or 0 to 5. both side close bracket, and you can check 0 will be lying here and 5 will be lying here. So at 0 you can find value, it will be 7 only, you can find it directly, and at 5 if you can find, it will be 25 plus 20, 45 plus 7, I think 52 upon 6. So this will be 26 upon 3. So you can see the value at 0 was 7, then it came down to 6 at 1, then it rose to 26 by 3. But still 26 by 3, 26 by 3 is bigger than 7. So my range in this case, if x is like this, then range would be 6 comma 26 by 3. I hope you all are getting what I'm saying. So this is how you can find the range. If your x is lying on both sides of -1, then also you can do the same way I told you for linear upon linear. So that was one case of quadratic upon linear. Now coming to second case, when numerator has real roots. Okay, here numerator was not having real roots. Numerator has real roots, equal or distinct, and roots of denominator lies on either side of the roots of numerator. Either side means either on the left side of both the roots or on the right side of the both the roots. So here numerator very clearly seen, roots are 0 and 8, whereas the root of denominator is -1. So it is not lying in between, it is lying here. Now as I told you, -1 will be a dangerous line, a danger line, isn't it? Why it is danger line? Because you cannot put x is equal to -1. Now using wavy curve method, we will get signs of this expression like this. On right of 8 it will be positive, then negative, then positive, and then negative. Okay, so 3 times sign is changing. Okay, now at 8 it has to be 0, at 0 also it has to be 0, at -1 it will be going plus infinite. So rough diagram will be going like this, and at -1 it will be -1 negative, it will be -infinity, and it should remain negative, and then it should go -infinity also, because numerator has 2 degree, denominator has degree 1. So this is how this diagram would be. Okay, in fact if you check, if you compare with the graph of earlier one, you can see it is actually the same diagram as we did for case 1. You have just actually lowered this graph of case 1 by certain value, so that one of the portion is intersected by x-axis. That is the only difference. By adding some number or subtracting, you can get first case to the second one or second to the first one. Now once again, if you want to know what will be this minima or what will be this maxima, okay, there is the same method as I told you earlier. Let me do the calculation, but let me show you some fair diagram before that. So how we are going to do it? Again, we will be writing this as x plus 1 whole square. Okay, and plus 2x, here it is -8x, so I have to write -10. Then I'll write x plus 1 here. Now constant term 1 minus 10, and I need to have 9 here, so that constant value becomes 0 as it was there, and whole divided by x plus 1. Okay, so you can check what we have got. It is -10 plus x plus 1 plus 9 upon x plus 1. So you can see this bracket can again be simplified using AMGM. Okay, this will be greater than or equal to 3 when x plus 1 is positive, and this expression will be less than or equal to -3. I think I have made a mistake. It will be greater than or equal to 6 by using AMGM. Because how do we use AMGM? X plus 1 plus 9 upon x plus 1 divided by 2 will be greater than or equal to under root of product of these two. So 3 here. So 6 will be here and -6 will be here. And this will be when x plus 1 is negative. Now when will be the equality? Equality in this case will be if x plus 1 is equal to 3. That means x plus 1 and 9 upon x plus 1, they are equal. So x will be equal to 2. So this is my point of minima. You can check. You can find this using differentiation also. I'm repeating that thing. And here also this equality will happen when x plus 1 is equal to -3. That means x is equal to minus 4. So this point of maxima here will be when x is equal to minus 4. Now you can find the range easily. I will just leave this for you, that minus infinity to whatever value corresponding to minus 4, and then whatever value corresponding to this 2 to infinity. And dear all, let me tell you one thing. If I am having, yeah, no. So this minima will always be lying above this point of maxima. So you can say that if I draw a line parallel to x-axis touching this point here, then there will be a gap always. You can never have a point, you can never have a situation where this point lies below what this point is. Okay, there is a reason behind that. Actually, if you are going to have that situation, then there will be some line parallel to x-axis. There, this graph will be intersected at 4 points, isn't it? At 4 points. Okay, that means you will have 4 different values of x for which you will get same value of y. What I'm saying, let me repeat. If this right portion of the graph lies below this left portion of the graph, so that or let me put it other way, that maxima of this left portion is above than minima of this right portion, then there will be some line parallel to x-axis which will intersect this graph at 4 points, which means same value of y but at different values of x. Okay, but if you remember that our normal method, when we do the cross multiplication, we only get quadratic in x. So there can be only 2 values of x at max for which we can get same value of y, not 4 values of x for which we will get same value of y. I hope you are getting what I am saying. So there will always be a gap in between these two numbers. Okay, maybe I will take this thing up in our other session, but let me go ahead for the third case of this quadratic upon linear. Okay, now quadratic upon linear, when numerator has real roots and roots of denominator lies between the roots of denominator. Okay, now how this will be done, please see. First of all, the roots of a numerator are, I think, 1 and minus 5. Let me take this as minus 5 and this as 1. And this is minus 1, which will be lying here, somewhere here. So this danger line this time is lying in between. Okay, using wavy curve method, positive here, negative here, positive here, and negative here. So how the graph would be, at x is equal to 1, this numerator will become 0, whereas as x approaches to infinity, positive side infinity, this numerator being quadratic, denominator being linear, it has to go to infinite. So this should go to infinite like this. Whereas towards the right of minus 1, okay, this numerator, this denominator will be approaching towards very small value, whereas numerator will be finite value. So here this will be taking minus infinity because it has to be negative, so minus infinity it will be. About this danger line always, my graph will be either minus infinity or plus infinity. Similar to this, because at minus 5, numerator becomes 0, so our graph will be like this. Okay, so what you can see, it has become very simple, isn't it? That we have two portions of the graph, both are such that they are going from minus infinity to plus infinity. So range is going to be always plus infinite. Range is always going to be minus infinite comma plus infinite. In fact, every value will happen 2 times. One from minus infinity to minus 1 when your x is, and when your x is from minus 1 to plus infinite, again minus infinity to plus infinity we will be having the values. Some fair diagram can be like this. Now why it is happening so? If I use that same AMGM method, will it work here also? Let us see. I can write this as x plus 1 whole square. Okay, so 2x has come here. Now to make it 4x, I'll write 2 common, x plus 1 here. And constant term will be 1 plus 2, 3. And because we have here 5, minus 5, so I have to write minus 8 here. And whole divided by x plus 1. So what you can check here, that unlike 2 previous cases, we are getting 2 plus x plus 1 minus 8 upon x plus 1. So you can check if I write like this, plus here and minus 8 upon x plus 1 here. So one of the term is positive, one of them is negative. So AMGM cannot be applied. AMGM can be applied only on positive numbers, or in a special case by doing some substitution you can apply it on both negative also, as I did for last two cases, but here it cannot be applied. So finding maximum or minimum is out of question. In fact, for this expression x plus 1 minus 8 upon x plus 1, if you do the differentiation, I think you will be able to find it very easily that this differentiation gives you 1 plus 8 upon x plus 1 whole square, which says that this is always going to be positive. That means graph will always be increasing. It can be decreasing also in some scenario depending upon the coefficient, but in this case it is strictly increasing. So I hope you understand that when root of denominator lies between the two roots of numerator, root of denominator lies between the roots of this numerator, then you will be having graph like this and range will be all real number, and that is the easiest of the cases because you don't have to do that AMGM also, because that is just not applicable here. No point of maxima, no point of minima. Okay, so let us move to next one. In fact, here if somebody gives you some value of x, let us say some minus 427, something like that, and let me subtract minus 1 here. So here this will be very much easy, isn't it? Because minus 4 to minus 1 we have to go, and then minus 1 to 7 we have to go. So maybe somewhere here 7 would be. So you just have to count the value at minus 4 and at 7 and just write as two sets, union of two sets, you will get the range. Okay, so that is what I said in the beginning, that whenever you get the value of x which is not entire range, entire real number, then that method of making quadratic doing d greater than or equal to 0 will not be that useful. Okay, now coming to linear upon quadratic, and the first case is where this denominator, where quadratic case is not having any real root. In fact, this is just the reciprocal of my first case of quadratic upon linear. The normal method you already know, by making a quadratic after doing cross multiplication, doing d greater than or equal to 0. I will tell you the other method, because denominator is not having any real root and numerator is having only one real root minus 1, but this time it will become equal to 0. It will become equal to 0, but because denominator is quadratic, numerator is linear, so as x approaches to infinity or minus infinity, in both cases the value of this function should approach towards 0. And by wavy curve, here it will be positive, here it will be negative. So the graph will be something like this. In fact, you can think of, I have taken the same example which we took here also. Okay, so whatever we got here, you just have to do the reciprocal for each and every point. In fact, these kind of points which we got as maxima and minima by use of AMGM, we can identify they will be here also and they will be same numbers. Let us see how. First of all, let me show you the fair diagram of this particular case. Now, what will be the point of maxima here and what will be the point of minima here? Now, to do the same thing, this thing, I will be writing it like writing 1 upon. In fact, you will be now thinking that we have done same thing that we did in our this quadratic upon linear case. So here actually we have to do that way only. Okay, so if I copy what I did there, I think this was, let me do the copy only. So it was 2 plus, yeah. So it was 2 plus x plus 1 plus 4 upon x plus 1. Now, when this x plus 1 will be positive, let me write it here. When x plus 1 will be positive, this denominator thing, that is 2 plus x plus 1 plus 4 upon x plus 1 is going to be greater than or equal to, you can check, 2 into 2, 4, 4 plus 2, 6. So this entire thing, if I do the reciprocal, 1 upon this entire thing will be less than or equal to 1 by 6. So isn't that point of maxima in that case? Because if it is greater than 6 and it is less than 1 by 6, that means this is a point where you will get 1 by 6, and other than that, when this x plus 1 is positive, you will be getting less than 1 by 6. So this is the point, and if you remember, this equality will happen when x plus 1 is equal to 2, that is x equal to 1. So 1 comma 1 by 6 is this point. And similar to that, when x plus 1 is negative, this 2 plus x plus 1 plus 4 upon x plus 1 thing. Please see this thing. Here, if we apply ANGM on it, it will be less than or equal to minus 4. Less than or equal to minus 4 plus 2, so it will become minus 2. Let me write separately for this thing. It will be less than or equal to minus 4. And this equality when x is equal to minus 3. In fact, x plus 1 is equal to minus 2, so x is equal to minus 3. At minus 3, the value will be minus 2. Minus 3, the value will be minus 2. So you can see how the graph is progressing. It is going from 0 negative to minus 2 here, then going up, maximum value 1 by 6, then going down, going towards 0 plus here. So range in this case, you can see easily will be minus 2 comma 1 by 6, where minus 2 and 1 by 6 both are inclusive. Now depending upon someone gives you what portion of x, you can now identify which portion of graph is to be taken to find the range. Okay, so this is how this case 1 can be dealt with. Now coming to linear upon quadratic case 2, where denominator has 2 roots and roots of numerator lies on either side of roots of denominator, means it will be lying either on left or on the right hand side. I have taken once again the reciprocal case of our first quadratic upon linear case. So here you can check, you will have 2 roots of this denominator 0 and 8, and minus 1 is the root of this numerator. So these 0 and 8 will be the danger line this time. And by wavy curve method, plus on the right of 8, between 0 and 8 it will be negative, then positive between minus 1 and 0, and then negative here. Now because at 8 this cannot be 0, at 8 actually it is not defined, but on the right it will be becoming plus infinite, because denominator is approaching to very small value and numerator is finite value, so infinite. And because it is quadratic in denominator, it is linear in the numerator, so as x approaches to infinity, it will approach towards 0. Whereas between 0 and 8, because both are danger line and in between there is no change of sign, so graph will be looking like this. Okay, this point of maximum may not be lying exactly between 0 and 8, though it may be so, but it depends upon other roots as well. Okay, now coming to this 0 right, 0 left actually. So here it will be coming from plus infinity, it will become 0 at minus 1, because at x is equal to minus 1, this numerator is becoming 0. So it will be going down, but because it has to approach towards 0, because denominator is quadratic, numerator is linear. So as x approaches to minus infinity, this graph has to go towards 0. So there will be a point of minima, and there will be point of minima here between minus 1 and minus infinity, and there will be point of maxima between 0 and 8. Okay, the fair diagram may be looking like this. Here it is 0, here it is 8. Now if I copy the calculation I did for that example here, so first I will be writing 1 upon x square minus 8 whole divided by x plus 1. So let me write what we did there. So we got minus 10 plus here. So in this numerator, in this denominator actually, so 1 upon minus 10 plus x plus 1 plus 9 upon x plus 1. Okay, so you can make use of AMGM thing. So this expression x plus 1 plus 9 upon x plus 1, you can check. This will be greater than or equal to 6 or less than or equal to minus 6. Okay, greater than or equal to 6, equality will happen when x plus 1 is equal to 3. That means x is equal to 2. Whereas this minus 6 equality will happen if x plus 1 is equal to minus 3. So x is equal to minus 4. So you can check, this is the point minus 4 where minima is happening, and this is the point 2 where this maxima is happening. When this will be 6, x is equal to 2 means this expression will take value equal to 6. So 1 upon minus 4. So at 2, the value will be minus 1 upon 4. Whereas at this minus 4, at minus 4, it will be minus 6. So 1 upon 16, or you can say minus 1 upon 16. So these are the values of this minima and this maxima. If we have found there also, let me just check. Okay, I think we have not found, we have not written the values at 2 and minus 4. If we would have written, I think you can check, we will be getting exact reciprocal of what we got there. Okay, so this is how now you can conclude. If you want to, you can first conclude the range. So what will be the range here? So range will be first from 0 minus going up to minus 1 upon 16, then going up to plus infinity, then going from minus infinity up to this minus 1 by 4, then going down once again to minus infinity, then then infinity going towards 0. So what we can say about range here, I think this is coming from minus infinity, okay, then minus 1 by 4, union minus 1 upon 16 to infinity. And this minus 1 by 16 point should be lying above this point of minus 1 by 4. It has to be so. Otherwise, I told you there will be a problem. You cannot have 4 different values of x giving you same value of y here. So that will be the range. Now once again I am repeating the repeating the same thing, that if you are given some constraint on values of x, maybe from some finite value to finite value. Now looking at this graph, you will be able to find what should be your range. Okay, that is case number 2. Now coming to case number 3. In fact, let me just comment before going to the next case, that case when there was this case 2 is done. Now coming to case number 3. Now case 3 says denominator has 2 distinct roots and root of numerator lies in between the 2 roots. Above 2 roots means roots of denominator. Okay, in this case you can check the roots of this denominator are minus 5 and 1, whereas roots of this numerator is minus 1. So danger line are 2 here. Okay, at minus 1 this has to become 0. So using wavy curve method, it is positive here, then negative here, positive here, and negative here. So because denominator is quadratic, numerator is linear, so this graph coming from infinity will try to go to 0 here, and then coming from here, and it will go like this, and then coming from here, and it will be going towards 0, approaching towards 0. So you can check the graph will look like this. So the graph is totally strictly decreasing wherever it is defined. So the Fair diagram could be like this. Now the reason behind why it is always strictly decreasing, you may find either by dy upon dx, or same way I told you in our earlier questions, that x square plus 4x minus 5 upon x plus 1. I think I have taken this also from our one of the questions earlier of quadratic upon linear. So we got 2 plus x plus 1 minus 8 upon x plus 1. So if I copy that calculation here, it will be 2 plus x plus 1 minus 8 upon x plus 1. So you can see AMGM cannot be applied. In fact, if you do the differentiation dy upon dx here, you will get 1 upon square of this denominator thing with minus sign here into then differentiation of this. So this will be 1 plus 8 upon x plus 1 whole square. So you can check this has become actually negative. So this will be decreasing everywhere. So whenever this is the situation, you will get like this only. Okay, I have taken some example, but you can verify for other scenarios as well. Now case number 4 for this linear upon quadratic, when denominator has real but repeated roots. Okay, so in this case, what will happen? This minus half, that is the root of this denominator, it is repeated, and minus 1 is lying here. And obviously this root of this numerator will be lying either on the left or on the right, because this is having both roots to be same. If this is also having same root as that of denominator, then you can cancel that one of the factor. Then it will be just 1 upon linear. Okay, that can be dealt separately. But here this danger line is minus half. Okay, and using wavy curve method, it will be positive here. And here also positive, because at minus 1 by 2, sign will not change because you have repeated root. And then negative here. So how the graph is going to be? About minus half, it will be minus, it will be going from plus infinity and towards, I think, 0 here. Okay, and then it will be coming from minus infinity. At minus 1, it will become 0. Sorry, I have made some mistake, just 1 minute. Yeah, because sign is not changing, so it will be coming from here only. Yeah, and then because it has to go towards 0 as x approaches to infinity, so there will be 1 point of minima here. And there is one interesting thing here, that there is only 1 point of minima. There is only 1 point of minima. Why it is so? Let us see. Let us see. And fair diagram, if we draw, it will be something like this. Okay. Now, to know why it is only 1 point of minima, we can make use of either AOD or by AMGM. So let us do both of them one by one. So first I will write this as 1 upon 2x plus 1 whole square upon x plus 1. Okay. So this will give you 1 upon 4x square plus 4x, okay, plus 1 whole divided by x plus 1. And we can write this as 1 upon, I'll take 4 common and I'll write x square plus 2x plus 1, so that it becomes x plus 1 whole square. For that I will have to subtract by, I think, 4x. So taking 4 common, x plus 1 here. So this 4x here also. 4 minus 4, 0. So just 1 will be added here upon x plus 1 here. Okay. So here we will be getting 1 upon minus 4 outside plus 4 into x plus 1 plus 1 upon x plus 1. Okay. So you can check that when this expression will be greater than or equal to, this expression will be greater than or equal to, I think, 4. 2 into under root of 4, so 4. And this equality will happen when x plus 1 is positive, when x plus 1 is positive, and when it is coming out to be, let us check, it will be x plus 1 is equal to, I think, 1 by 2. And you can see this is giving you exactly that value which is not actually possible. So actually the value which we can expect where this maxima or minima will occur, actually that is not possible, corresponding to when x plus 1 is positive. In fact, when it is 4, you can check, it will become not defined. Actually, this point is when you can see that this graph is going towards infinite. So someone may think of that it is a point where, maxima is coming, because we will be, getting back this value, but actually at minus half, this graph is not defined. So saying that it will be point of maxima, it is wrong. But here, when x plus 1 is negative, okay, when x plus 1 is negative, you can write this again, minus 4 plus 4 into x plus 1 plus 1 upon x plus 1, and this thing will be less than or equal to minus 4, and equality will happen when x plus 1 is minus half, so x will be equal to minus 3 by 2. So this point will be when x is minus 3 by 2, and this is the point of minimum. And you can find corresponding minimum value. Actually, it will be minus 1 by 8. Minus 1 by 8, but when it is minus 3 by 2. Okay, so this is the reason why only one point of minima is occurring, not maxima. In fact, if you want to do the differentiation, there also you will find something interesting. dy upon dx, if you do differentiation, will give you 1 into 2x plus 1 whole square minus 2 into 2x plus 1 into 2 into x plus 1, and whole divided by 2x plus 1 whole power 4. So you can check one of the factor 2x plus 1 is getting cancelled in the numerator and in the denominator, and after simplification we will be having 2x plus 1 minus 4 into x plus 1. So you can check there is only one value of x where dy upon dx is becoming equal to 0. Okay, and that value will be x is equal to minus 3 by 2. It can be checked because this numerator thing will be minus 2x minus 3 upon this whole cube. So putting this equal to 0, x is equal to minus 3 by 2 is the only point where this dy upon dx is becoming equal to 0, and that is the point of minima. By doing differentiation, you can check whenever there is a repetition of root in the denominator, there will be factor that will cancel always. So in the numerator, we will be having only a linear factor that will give us only one value of x, and we can expect this point of minima. This can be point of maxima also, depending upon what are the coefficient. If there is a minus sign, I think this can be point of maxima also. Okay, dear all, I have taken all those cases where leading coefficients are positive. If you take leading coefficients to be of opposite sign, then this scenario will become reverse, and you can do it yourself. Okay, so this is case number 4 of linear upon quadratic. Now coming to quadratic upon quadratic. Now here this is the general case of quadratic upon quadratic. Now normal method can be that you make quadratic do d greater than or equal to 0, that you can do it. But I will tell you that if you want to do it using graph, one of the method could be that you try to write this as 2 upon 3 into 3x square plus 4x plus 5. Okay, and plus here would be 2x square has been taken care of. Now to have 3x here, we are having 8x upon 3, so I think x by 3 will be required here, so that 8 plus 1 9 upon 3 will become 3x, and constant term is 10 by 3, and I want 4 here, so I think 2 by 3 here. So 10 plus 2, 12 by 3, yes, and whole divided by 3x square plus 4x plus 5. So what I have tried to do by doing this thing, that 2 by 3 is a constant plus 1 linear, 1 upon 3 into x plus 2 upon 3x square plus 4x plus 5. Now if you want to make graph, I think linear upon quadratic, one of these scenario which I have discussed already, you can make use of, and then you can find the graph and you can find the range. This 2 by 3 will be added to every value corresponding to this linear upon quadratic. In fact, if you check, this denominator is having 16 minus 3 into 5 into 4, I think 60, so it is negative. So denominator is not having real root, only one root is real there. So I think graph, if you remember, it was like this. Okay, and we have to just lift this graph by 2 by 3. Maybe you can bring this x-axis down by 2 by 3 depending upon what is my minimum value. It may be intersecting this graph, or it can be checked by this thing. The graph, this numerator here was having a quadratic whose d is 9 minus 2 into 4 into 4, 32. This is also negative. So this is also having imaginary roots. So my x-axis will be lying here. Why I am saying so? Because you have raised this graph by 2 by 3 of this linear upon quadratic, And because this numerator also is not having any real root, so this x-axis should be such that it should not intersect this graph at all. Okay, so you just have to raise, just remember, you just have to raise the graph and you will get the answer. Okay, so this value, this graph will be actually corresponding to y is equal to 2 by 3. Now getting minima and maxima, and you will be able to find the range. Okay, so every quadratic upon quadratic can be done by a method of linear upon quadratic, but still I will give you a few other cases as well. Like case 1, when denominator is having imaginary roots but numerator is either having or not having, both I have taken. So here what you can see, 11 square is 121 minus 2 into 4 into 2 is 8, and 17 into 8 is I think 136. So it is negative. So in this case, this numerator is having imaginary roots, whereas here 64 minus 44, this is having real roots. Okay, now if I try to make them the way I did earlier, so it will be 2 plus, please check, x square plus 4x plus 7 here, and what will be remaining? I think 3x plus 3. So I can write this as 3 into x plus 1 upon x square plus 4x plus 7. Okay, whereas in this case where you are having real root in the numerator, I write this way, it will be 1 plus 4 into x plus 1. So don't you think that they are both same thing? Means this linear upon quadratic terms are same. In one of them it is multiplied by 3 then added 2. In one of the case multiplied by 4 then added by 1. Okay, so because this numerator is not having any real roots, so the graph, if my x-axis like this, then maybe graph will be like this. Okay, and this will be I think 2, y is equal to 2 line. Whereas in the other scenario, because numerator is having real roots, this is my x-axis suppose, then the graph will be like this. And this line will be x is equal to 1, and this line will be y is equal to 1. I hope you are getting it. Why it is intersecting this x-axis at 2 points? Because this numerator has 2 real roots. So at these values of x, it has to give you value equal to 0. Okay, and we are raising this graph by 1. So you can think of this width is 1, or you have brought this x-axis, if graph would have been corresponding to this, down by 1 unit. Okay, I have drawn fair diagram also. Okay, so this is corresponding to first one, this is corresponding to second one. Okay, this is x-axis, and these are values of y equal to 1, I think, that I plotted there, and y is equal to 2 here. Okay, now coming to scenario 2, denominator has real roots. Okay, and exactly one root of the numerator lies between the roots. Okay, so if you see the roots here are 1 and minus 5, 1 and minus 5. Let us first try to write that way. I have been writing, so this will be 1 minus x square plus 4x minus 5, and to have it 5, I think there will be plus x here and plus 1 here. X plus 1 upon x square plus 4x minus 5. Yeah, and I think we have done question on this. If you remember, this is linear upon quadratic. Roots here are minus 5 and 1. Its root is minus 1. So whatever we got there, okay, these were the danger line, minus 5 here, 1 here, and 1 here. So if you remember, we plotted graph like this. And here it will be going like this. Am I missing something? I am plotting graph only for linear upon quadratic. So 1 is the root, minus 5, 1 are the danger line. So positive, negative, positive, negative. Yeah, it will be negative throughout. So it will be like this. Yes. Yeah. Now, because you are adding 1 to it, that means we will bring this x-axis down by 1 unit or entire graph by 1 unit up. That means my new x-axis will be somewhere here. And you can check that whatever roots you have got for this quadratic, they will be one lying here and one lying here. And you can check. This is the root, one of the root lying between the two roots of the denominator between -5 to 1 and one root before -5. So whenever your graph of quadratic, your quadratic is such that exactly one root of numerator is lying between two roots of the denominator, your graph will be like this. So it will be strictly decreasing always or strictly increasing depending upon the relative signs of of coefficients. Actually it will depend upon the coefficient. So if we draw it directly, you can do it like this also. Can we find the roots of this numerator? Let me check. It will be -5 plus or minus root over 25 plus 20, so 45 upon 2. So if I take 45 as almost 7, so this will be around -5 minus 7, so -6. Yeah, so this root is -5 minus 45 upon 2. It is left of -5. Other is -5 plus 7, so 2 upon 2, around 2, but it will be slightly lesser than 2 here, so slightly lesser than 1 here actually. So that is -5 plus root 45 upon 2. Okay, so this one was the danger line, -5 was the danger line, and these 2 points are where this numerator is becoming 0. So this is how your graph would be. It will be strictly decreasing, and this is the line I told you, y is equal to 1. Okay, and from this also you can think of what will be the range of this quadratic upon quadratic. Okay, now coming to case number 2, when denominator has real roots but all other cases except case number 1, means all other cases means numerator has no real roots like this, or numerator has roots both lying between the roots or outside the roots of the denominator. Okay, let us come one by one. First, this is the scenario where numerator is not having any real roots. So danger line at 0 and 8, and that are the only critical points. Nowhere else change of sign will occur. So here you can see the graph should be coming from plus infinity here and going towards 1, because both numerator and denominator are having same quadratic. Okay, leading coefficient is also same 1 1. So at infinity limit will be 1, whereas here it will be like this, and here again this will be like this. At one of the side it will be having minima. Okay, at one of the side it will be having minima, whereas at one of the side it will be going just decreasing like this. And where it will be, we can think of it. Okay, actually you can write this like, if I write it 1 plus 8 common x plus 1, yeah, x plus 1 upon x square minus 8x. Okay, so if I draw graph of this thing, okay, if you remember linear upon quadratic, only linear upon quadratic, so roots are 0, 8, 0, 8 and -1 here. Yes, -1 here. So the graph of this linear upon quadratic should have been these two danger lines, and here it will be going towards 0 because linear upon quadratic, then going down like this, and here coming from here at -1 it will be 0, and then to take value towards 0 there has to be a point of minima here. Now because this root -1 is lying on the left of 0 and 8, so here also this minima will occur on the left of 0 and 8. Actually between this graph and this graph, the only difference is that we have raised this graph by 1 unit, isn't it? After multiplying by 8, we have raised this graph by 1. So here this graph will be similar to this one only, just a raise of 1. So hence this point of minima will be lying on the left of 0. Actually, it depends upon where this root is lying. If it would have been lying on the right of 8, then we would have got this point of minima on the right of 8. Okay, now similar to this, I have drawn a fair diagram also. Yeah, this is the graph of this one. Okay, now let me show you the graph of this second one. Here also, if I write this as linear upon quadratic, it will become 1 x square minus 8x. So minus 8, I need 12 here. So I think 20x plus 1 here. Yes. So it is same thing as we draw for this one, but here we are multiplying by 20 and then adding 1 to it. Okay. So what will happen that if you draw the graph of this thing, two danger lines, 0, 8, minus 1 here, and here you can check this is having, I think, real roots. Let us check. Minus 12 plus or minus root over 144 minus 80. 144 minus 80 is 64 upon 2. I think we are getting rational roots. It could have been written the 10 into 20. Yeah, 10 into 20. So roots will be minus 10 and minus 2. You can check. Minus 10 and minus 2. That's correct. So one root is for this is lying on the left of it. I think both roots are lying on the left of it. Means lying outside the root of the denominator. The roots here are minus 2, minus 10, whereas roots here are 0 and 8. So both roots are lying outside the roots of this thing. Okay, so in this case, what will happen, please understand, we will be, let us first draw the diagram of this thing, which was like this. Okay, and here point of minima and here like this. And always remember this maxima here cannot go above that minima here. So graph should be like this. Now, because this is having two real roots, okay, this is having two real roots, so I have to raise this graph by 2 units. Sorry, we have to raise this graph by 1 unit here. And how this will be done, please see, we will be bringing x-axis below. So x-axis below, but roots of this numerator are lying on the left of 0 and 8. So my x-axis will still be here only. It will not go that down that it intersect the graph of this portion. It will only intersect the graph of this portion, and this will be minus 2 and that will be minus 10. I hope you are getting that. So you can check, this is the graph of second one. Let me see. Yeah, same thing. This is minus 2, this is minus 10, this is 0, this is 8. Now coming to the next one. Next one means this one. So if I see the roots here are real, but roots would be 9 plus or minus b square 81 plus 4. So it will be 5 upon 2. So roots would be 9 plus 9, you can say almost 9.1 something or 9.2, and other would be slightly negative minus 0.2, you can say. Yeah. So that means the root, if I compare with 0 and 8, one is lying on the right of 8 and one is lying on the left of 0. Okay, let me draw the diagram of this thing on this left portion here. First, I will be drawing the diagram of this thing. And let me do it quickly. This is linear upon quadratic portion. And if I write that method linear upon quadratic, so x square minus 8x, and here there will be, I think, minus sign, because x square minus 8, I will need x here plus 1. Yeah. So 1 minus x plus 1 upon x square minus 8x. Yeah, that is correct. So if I draw the diagram of only this thing, let me take another slide. I think I am not having sufficient space here. Yeah. So what we did here, we found this case is actually 1 minus x plus 1 upon x square minus 8x. And roots of numerator are 1 left of 0 and 1 right of 8, the roots of denominator. Okay, so if I draw the graph of this x plus 1 upon this thing only, it will be two danger line at 0 and 8, and one root is minus 1. Okay, so this will be going like this, then like this, and then like this. There will be minima and then approaching towards 0. Now because there is a minus sign, we have to reverse the graph, the shape of this graph. So how this will be, I think here it will go like this, here it will go like this, and then from here point of maxima, and then it will go like this, and then we have to add 1 to it, and we are adding 1 to it means the graph will go above. This graph will go above, that means x-axis will go down, that means my new x-axis will be taking place somewhere here. So you can check this this expression here is becoming 0 because this is the x-axis. This expression is becoming 0 at this point, which is lying on the left of 0, and there is one more point that is lying on the right of 0. Okay, that is the reason why when both the roots of numerator are such, one lying on the left, one lying on the right of this denominator, will be like this only. And this can also be thought of coming from linear upon quadratic only. In fact, if you noticed, all these three cases are derived from that linear upon quadratic, where quadratic has two real roots in the denominator, and linear is having root either lying on the left or lying on the right. So all these three cases are taken care of in one go. So you can see this is how the graphs of these three things are. They all are derived from linear upon quadratic. Of which type? Let me show you it here. Linear upon quadratic. Which one? This one. This was my original linear upon quadratic, and by making some changes to this, we are getting that required quadratic upon quadratic. Okay. After doing all linear upon linear, quadratic upon linear, linear upon quadratic, and quadratic upon quadratic, I will like to mention two cases. One is when quadratic upon quadratic has just one different thing, that is the constant. Okay, so in this case, let me write it on separate slide. So this can be written as 1 plus c1 minus c2 upon ax square plus bx plus c2. So this will be actually 1 plus some constant upon quadratic. And depending upon whether quadratic is having real roots, same roots, or imaginary roots, you can make three different cases. For example, here, if you think of the first one, this is just 1 plus 4 upon, and this denominator is having the factors x plus 5 into x minus 1. So if I have to find the range of this expression which I have enclosed in the curly bracket, it will be minus 5 here and 1 here. So this is the danger line. Okay. And for this particular portion, if I write the range, here it is positive, here it is negative, here it is positive. So graph will be going something like this. I think we are now much aware of how these things are done. And in between, it will be going like this. And here it will be going like this. Okay, as x approaches to infinity or minus infinity, in both cases this value will approach to 0, and here it will be going to infinity. Similarly here also from 0 to infinity, whereas between minus 5 and 1, this will be just reciprocal of whatever minimum value would have been for this particular quadratic, and that will occur at just midpoint of this minus 5 and 1. That is, I think, minus 5 plus 1 by 2, that is minus 2. So at minus 2, this will be the point of local maxima. So you can write the range from minus infinity up to this point, and then 0 to infinity. 0 open bracket. At this point, it will be closed bracket. Now similar to this, it can be done for other cases as well. Here it will be 1 minus 1 upon, and this quadratic in denominator is having imaginary roots. Okay, so you can draw the diagram of this directly also for this portion only. Let me first draw for this one here, because it is not having any real root. You can check d is negative, so its value will become 0. This entire expression value will become 0 at infinity, but it will be maximum at the point where x will be equal to minus 3 by 4. This is same point where quadratic has its vertex. So the graph will be going like this and like this. Okay, and we have to subtract this thing from 1. So maybe in 2 steps you can do it. First you can put minus sign outside, so then the graph will go like this, and then you will add 1 to it, so your x-axis will come down here. So this is how you can check what will be the range of this kind of function. Okay, so this kind of question I will suggest just do by quadratic directly. Now similar to this, here I have taken 1 minus 2 upon x minus 1 whole square. So here once again we are having 1 as a repeated root. So if I draw the graph of this thing alone, okay, this will be a danger line, and this will be positive infinity to 0, and here also positive infinity to 0. Then we will just take the negative of this, so it will come like this, and then we will add 1 to it to get the final range. Okay, so this is one thing. The second thing which I wanted to tell you was, when denominator and numerator have some common root, one common root, if they are having both common root, then it will be a constant value only. But many times we ignore this fact they are having common root. For example, here if you check what can be the factor, I think I can write this as I need minus 4 as product, so plus 4 minus 1. So one factor will be 2x minus 1, and other factor would be x plus 2. Okay, whereas in the denominator 3 into 24 minus 24, so I will write this as plus 6 minus 4. So 3x minus 4 as one factor, and x plus 2 as another factor. You can check 3x square plus 6x minus 4x minus 8. Yeah, so this is common factor. So in such case, you should understand it is just linear upon linear. It is not quadratic upon quadratic. You just have to deal like linear upon linear. But dear all, please understand here, in this case, if we were doing for this linear upon linear, ordinary linear upon linear, where x plus 2 was not in the picture, then its range would have been r minus, as I told you, 2 by 3. The coefficient x, the ratio of coefficient of x, 2 by 3. But because x is equal to minus 2 cannot be put, so when x is equal to minus 2, we put in this linear upon linear, you can check it will be minus 4 minus 1, so minus 5, upon minus 6 minus 4, so minus 10. Let us check once again. It is coming out to 1 by 2, I think. So minus 4 minus 1 minus 5, and minus 6 minus 4 minus 10, so 1 by 2. So this 1 by 2 is coming at x is equal to minus 2 for this linear upon linear. But as you know, we cannot have x is equal to minus 2 in this original function, so we should be subtracting this 1 by 2 also from the range. Okay, so we will be getting range as half, and 2 by 3 being excluded from the entire range, entire real number. So that will be the answer. I will like to tell one very interesting fact about this kind of question, because many people forget or they just ignore that there was a common factor. So what they do, they just do 3 into y into x square plus 2y into x minus 8y is equal to 2x square plus 3x minus 2. And then it will be a quadratic like this, 3y minus 2 into x square plus 2y minus 3 into x and plus 2 minus 8y. Now, if you do this question in ordinary method, what you will find that d will come out to be perfect square. Perfect square. And we look for greater than or equal to 0. So it gives one impression that range is going to be all real number. Because for every y, perfect square has to be greater than or equal to 0. Now, I will leave this question you to ponder upon that why it is coming out to be perfect square and how to deal with such situation, just in case you forget to note that there was a common root. But if there are common root you can find, then this will be just linear upon linear. You don't have to do anything else. So this is something that you need to think about. Now I'll be telling you teaser question, but before that, everybody, let me tell you Vedantu Eklavya, as I always say, if you are looking for JEE advanced preparation, this is one very good thing, one very big thing in online domain. So just come to know about that thing by googling it, and you will find it very useful for you. This is the link of topper notice board where we are putting all sort of information about new batches coming up or new batches going on in these batches. This is the QR code for the same thing. Just follow it. You will come to know what is going on in Vedantu. Okay, Vedantu topper board. Now this is the link for those students. I think this is old one. Yeah, this is the link for those students who will be writing JEE Advanced in 2023. This is the QR code. We are putting all important information regarding Eklavya 2023 in this Telegram channel. Please follow it. Please join it. We will be putting all relevant information there. Same for 2024 aspirants. This is the link for Telegram channel for that channel where 2024 aspirants are there. So please join it. Dear all, this is the link, this is the QR code for one YouTube channel called as V Impact, where we are putting solutions of JEE Advanced, KVPY, ISI CMI. They are yet to be put. They will be very soon there. And here we have put solutions question wise, and many questions you will find unique solutions, alternate solutions. So please go through it. Now this is the teaser question. Dear all, this is the same question which I gave you last week also. In triangle ABC, P is an interior point with BC is equal to 3, AC equal to 5, BA is equal to 6. From P, perpendiculars PA dash, PB dash and PC dash are drawn to altitude AD, BE, CF such that AA dash is equal to BB dash is equal to CC dash. We have to find the length AA dash. Also, I'll give you bonus if you can find that point P, how much distance of P is from A. Okay, so that is all for today. If you have solved this question, do not forget to send this to eklavyaSupport@vedantu.com with subject line teaser solution maths. We will check your solution, and if we like it, we'll contact you, and we will like to have with us to have future things for whatever you need. Okay, so that is all for today. Thank you so much, everybody. Bye. Take care.